Exercise 1.4 problem 3 solution. So here we have set A given, set B given, and the function from A to B equal to 1, 2, 3, that is f1, f2, f3 are given here in terms of ordered pair. We are asked to find the type of function. Okay. So let's draw the ordered pair is given. So all these things are ordered pair. So let's draw an arrow diagram. So you have these two ovals, and you list out all the elements of A here and list out all the elements of B here and map them or connect every element of A to element B as per this ordered pair. Okay, so here 10 is connected to 1, so 10 is linked to 1. Then draw an arrow. Okay, that is mapping. So 11 is mapped to 11 and 2. Okay, that's a function here. So 11 is mapped to 2. This 12 3, so 12 is mapped to 3. And 13 5, so 13 is mapped to 5 through an arrow. Okay, then 14 3, so 14 is mapped to 3 using an arrow. So this is an arrow diagram. Arrow diagram is very clear because you can visually see what is happening here. You can very clearly see 0 in set B has got no pre-image, right? Then you can see 3 has got 2 pre-images. 12 is also mapped to 3, 14 is also mapped to 3. So it is not an one-to-one function because all the elements of A, if it is one-to-one, all the elements of A should have different images in B, but that is not the case here. 12 and 14 have the same image 3, so it is not an one-to-one function. Then every element should have a pre-image, right? In set B, 0 does not have a pre-image, so it is not an onto function, which means this function is neither one-to-one nor onto function. Okay, so you can see 0 element B has no pre-image in A, and 12 element A and 14 element A have the same image in B. Thus it is neither one-to-one nor onto function. But it is a function because every element of A has got an image, right? So it is a function, but only thing is that it is neither one-to-one nor an onto function. Now the next case we have to do same way, right? The ordered pairs is given, f2 is given, draw this first oval and the second oval, put all the elements of A, put all the elements of B, and as per this ordered pair map the elements of A to element of B. In all these cases you can see all the elements of A are connected or mapped to 1. This is nothing but a constant function. It is a function because every element of A has got an image, right? But all of them are mapped to only one element, that is 1. So in this case it is known as a constant function. Every element of A is associated or mapped with one element B. It is a constant function. Okay. Now let's go to the next case. Okay, so in this case function f3 is 10 0, 11 1, 12 2, 13 3 and 14 5. Let's do the ordered pair. So this ordered pair, let's convert it to an arrow diagram. Two ovals and list out all the elements of A, list out all the elements of B in the second oval, and map the elements or connect the elements using arrows as per this ordered pair. 10 is to be mapped to 0, 11 is mapped to 1, 12 2 is connected to 2 through an arrow, 13 is connected to 3 through an arrow, 14 is connected to 5 through an arrow. So that is what is done here, and you can see each and every element of A has got an image, so it's a function, and each and every element of A has got a different image. There is no crisscrossing of arrows. So all the arrows do not intersect. If they intersect, they have one common image, right? So each one have got a different image. So it's an one-to-one function. And all the elements of B have got a pre-image. So it is an onto function. So thus it is a one-to-one as well as onto function. And thus it is known as a bijective function. Okay. So I hope it's clear. If not, please go through one more time. It will become clear. Thanks for watching this video.